Hello, family. Welcome to another session of Maths Fanatics 24/7. In this question, we're going to be looking at the graph of a cubic function. Okay, as you can see on my graph, I have highlighted the special points. I always start by highlighting the special points. These 3 points, this one, that one, and that one, are my x-intercept. And then A and B are my turning points, A being my maximum turning point, B being my minimum turning points. So I give you an advice to always highlight the important points like y-intercept, x-intercept, turning points, points of intersection, and all that. Does make sense? Awesome. Parallel lines, horizontal lines, and all that. Does make sense? Perfect. So in this case, we're going to start by solving for 9.1. Okay. So they say the graph of f of x equals to 2x cubed plus 3x squared minus 2x is sketched below. A and B are turning points of f. C, 2 coordinate 4 is a point that lies on f. Okay. They want me to determine the coordinates of A and B. By the look of things, I can see that A and B are what? They are turning points. Remember what I said. I said on the turning points, you always do derivative equals to 0. Because on the turning points, the gradient is 0 on the turning points. So always, when the question asks you to do turning point, minimum, maximum, extreme points, and all that, local minimum, local maximum, you are going to do what? Derivative equals to 0. Perfect. And it does not matter whether it's a cubic function or it's number patterns or it's optimization. When the question asks you to do a maximum or a minimum, you do derivative equals to 0. Okay, perfect. So in this case, let me write my f of x here. So f of x equals to 2x cubed plus 3x squared minus 12x. So now, to get the derivative, I'm going to this times that. Remember, derivative, we take 3, we multiply by 2, we're going to get 6, and then we take the 3, we minus 1, which is 2. Then we do the same here. We take 2, we multiply the 3, which is 6. And then we write the x. And then we take the 2, we minus 1, which remains 1, of which you don't write. Here, remember, there's an invisible 1. So that 1 multiplied by negative 12 is negative 12. Then that 1 minus 1 will be 0. So here you're going to have x to the power of 0, which is going to be 1. So you're just left with negative 12. Remember, we said the derivative must be equals to 0. Awesome. When you're here, you can use a quadratic formula. Your A is 6, your B is 6, your C is negative 12 to get the 2x values. Right. But I'm just going to use a short method. So I'm going to firstly divide everything by 6. So here I'm going to have x squared plus x minus 2 equals to 0. And then my brackets are going to be x and x. So this is going to be plus 2 minus 1 equals to 0. Then x equals to negative 2 or x equals to 1. Right. Even if you used quadratic formula, you should still get to this point. So if you prefer using a quadratic formula, it's still okay. You'll still get the same answers. Perfect. So now we need to decide which x is for which letter. Perfect. The smaller one must always be on the left. So negative 2 must go with the letter that is on the left because it's small. So negative 2 will go with A. And I can also see that this is the negative x-axis. This is the positive x-axis. So the negative x-axis will go with A, the positive x-axis must go with B. So obviously this will be x on A, that will be x on B then. Do we see it? And then to get y values, I'm going to substitute now. F at -2, you always substitute into the original equation. Don't substitute on the derivative. It's not going to give you an answer. It's going to give you 0, right? So you always, when you're looking for a y value or an x value, you substitute into the original function. Perfect. So I'm having 2 minus 2 cubed plus 3 minus 2 squared minus 12 minus 2. Right. We are quickly going to press a calculator and see what's the answer. But for so long, let's substitute 1 as well. So f at 1 is going to be 1 cubed plus 3, 1 squared minus 12, 1. Right. For those who don't understand how to substitute, this is what we do. You go to your original function, f of x. You just rewrite everything, right? But where there's x, you open brackets. Né? Plus 3. Then you open a bracket because there was x there. Then you put the square. Then 12. And then there's x, you open there. So all the x's, you replace them with the brackets. And then you're going to put the x value inside that you want to put. So for example, here I wanted to put a -2, of which I did put it there, here, and there. And also -1. Do we see it? Awesome. And then now we're going to quickly press a calculator and see what the solutions are. Right. So let's see now. So we're going to firstly have 2 in bracket, -2 cubed plus 3, -2 squared minus 12, -2. This gives us 20, right? So the answer here is 20. Which means, therefore, my point will be -2 going with 20, right? And we agreed that this is point A, okay? Then now we're going to substitute 1, right? Let's substitute 1 and see what we get. So I'll just do this quickly. We cancel there, we substitute 1. We cancel there, we substitute 1, right? I'm getting -7. So here's going to be -7. Therefore, coordinates of B is going to be 1 and -7. And then we have found the coordinates of A and B. Okay. Awesome. So let's do the next question. On the next question, which is 9.2, they want the coordinates, they want values of x, né? For which f is concave up. Okay, I'll show you both concave up, and if they said concave down, né? Concave down. Sharp. So for concave up, right, you need the second derivative of f of x to be greater than 0. Ne? For concave down, you need the second derivative of f of x to be less than 0. Perfect. So now concave up, remember second derivative means I'm taking the derivative and deriving it again. Remember this part here is my first derivative, right? You see there's 1 line. 2 lines means you are taking the first derivative and differentiating it again. So if I was going to differentiate this, this is what I'm going to get. 6 times 2, it's 12, right? Then we write x. And then 2, remember, we always minus the exponent with 1. So 2 minus 1, it's 1. So we have 1 there, but I'm not going to write it. And then here, we're going to have 1, because there's invisible 1 there, times 6 gives you 6, right? And then that 1 minus 1 gives you x to the 0. So x to the 0 will disappear, basically, because x to the 0 is 1, right? And then the derivative of constant is 0. So this part becomes 0 because it's a constant, right? A constant is a term without a variable. Awesome. And then we have this. Then we can easily solve the inequality now. Because I don't have space, I'll just quickly go there, which is 12x is greater than, I'm moving the 6 to the other side, it becomes negative. Then I divide by 12 both sides. Then x will be greater than negative 1/2. Right. Perfect. And then for concave down now, it's the same thing, but now your sign will just be facing an opposite direction. Do you get it? So this is for concave down. That is for concave up. Okay, awesome. Perfect. So, but the answer to this question, they wanted concave up. So you're going to give this one, right? Awesome. And now let's go to the last question. Okay. So 9.3, they want us to determine the equation of a tangent. Remember, a tangent is a straight line. So if they say I must determine the equation of a tangent, I know I'm looking for y equals to mx plus c. Because it's what? It's the tangent. And a tangent is a straight line, right? And then remember, what does the derivative mean? The derivative means gradient, right? This means gradient. Sharp. So at point of contact, the gradient of the curve, which is f prime x, and the gradient of the tangent are always the same. So this is the most important formula that I want you to know. The m of tangent is the same as the f prime of x, where they meet. Sharp. Remember, f prime is a gradient, and then this is also the gradient, so they have to be equal. But the exciting news is we know the x value where they're meeting. So we can further on to say the gradient of the tangent is the same as the gradient of the curve when x is what? When x is 2. So I can put 2 there. Awesome. So now I can come here and say f prime at 2 and see how much I'm going to get, right? Remember I said when you substitute, you just do this. You rewrite everything, but you open the brackets where the x is, and then you're going to put in this value that you have there. So it's 2 and 2, right? So now we're going to find f at 2. Let's see what f at 2 gives us, right? We're just going to punch that in a calculator. So we have f prime at 2, which is 6, 2 squared plus 6, 2 minus 12, right? That gives us what? 24. So I can easily see that f prime at 2 is 24, which is the gradient of the tangent. Awesome. So the gradient of the tangent is this. So now I can happily go to my equation and solve it now. So I have y equals to, the m is 24. So 24x plus c, right? To get c, it's always simple. You take the point, you put the x value here, you put the y value here. So the point that we're going to take is c, my x is 2, my y is 4. So where there's y, I'm going to replace by 4. Then 24. Where there's x, I'm going to replace by 2. Then that. Then I have 4 equals to 48 plus c. 4 minus 48 equals to c. Then negative 44 equals to c. Therefore, the equation of the tangent is the same as 24x minus 44. And then you should get your 3 marks there. Okay, the only important thing that you need to know about the tangent is the prime of the curve, which is the derivative of the curve, and the gradient of the tangent are equal at the point of contact. Ne? So this part is the most important part about this question. Ne? It helps you to get the gradient when you know the x value, which was 2 in this case, because I got it there. Do you see it? Which is 2. Awesome. And then I think we're done with this question. Okay. Please don't forget to share with family and friends and advise them to do so too. And if you haven't subscribed, please kindly hit the subscription button for more fire content like this. Thank you very much. Aluta continua.